Need to grab your player's attention? How about dangling something shiny for them to click? Or waving something in their face? Hi and welcome. In this tutorial, I will show you how to create just that kind of dangly wavy effect. Which one it will be depends on the location of your pivot. The core of the effect is rather simple, and you can find it in the chapters. But I'm going to wrap it into some functionality that will turn it into an easily reusable component you can slot into any of your projects. You'll be able to define which button press to react to, what to do on any kind of interaction, like hovers or clicks, and control the style of the effect with a handy animation curve and a pivot setter. The setup to follow along is pretty straightforward, and I'll just use a simple one. Create an empty child object on your canvas and name it something like dangle container or whatever. Size it however you need and create an image child object to it. You can make it fill the whole space of the parent object by clicking on the anchoring menu here, holding Shift and Alt, then clicking on the down right entry of the menu. Give this image object a good name as well. And you're already done with this setup in your scene. Let's head over to Writer and start writing some code. Since this script is part of a group of UI juice effects, maybe you have seen some of my other effects in the series before, I have one class all of them share called juicy enums. This dangle wave uses the mouse button enum to control with which button the player will be able to interact with the object, interaction type to control what kind of interaction can be triggered, the start behavior, which is hopefully self-explanatory, and the juice pivot, because this effect hinges, quite literally, on where the pivot of the object is located to switch from waving to dangling. Juice click behavior won't come up this time, since there are no A or B situations in the script, like there are in the card flipping one, for example. The ISJuicy interface is super tiny and used to trigger effects from a place that doesn't need to know what kind of effect it triggers, like the sequencer I'll show at the end, which can just trigger any effect handed to it. It is not required if you only need this one effect, but if you follow along more of my juice effects, you'll see this come up in every single one of them. Let's head over to the main class. Juicy Dangle Wave is called like this, so it is easy to find when attaching it as a component in the editor. Sometimes I think of adding a wave, sometimes a dangle. This fits both scenarios. You could also call it sway, which might work for both scenarios, but I've been too used to dangle wave at this point. It also sounds kinda silly. It inherits from monobehavior and implements a handful of Unity's built-in pointer interfaces, so that our players are able to interact with our object. iPointer-click handler for clicking, iPointer-enter handler and iPointer-exit handler for hovering, iPointer-down handler for while the mouse button is pressed, and iPointer-up handler for the opposite. We implement all 5 because we want to support several different ways to trigger the effect: clicking, hovering, and holding. Although this time we won't have huge differences between the ways this object is being interacted with, like we did in the Juice Flip tutorial. The last one in this list is ISJuicy, the tiny custom interface with a single method, trigger effect. The setup for this is just a single rect transform reference called object to dangle. That's a thing you'll notice going forward. While the effect handles both waving and dangling, I simplified it to just being called dangling going forward for brevity's sake. Then we have the control setup for the pivot. The juice pivot enum lets you choose where the rotation originates. Set it to top and the object hangs from its upper edge, dangling like from a nail in the wall or a pendant in somebody's hand. Set it to bottom and it tips from its base like the arm of a metronome. Left and right work well for attention grabbers on the side of the screen. A helper class called juicePivotHelper translates whichever option you pick into the actual vector2 value that gets written into the rect transform's pivot. There's also a custom option for when you've already set the pivot by hand and don't want the script touching it. I really recommend giving all of these a try during testing to see which effect speaks to you and fits your use case the best. Onwards to the animation controls. Dangle duration is the total time the main swinging portion takes from start to finish. The continuous delay has a show if attribute to it. That's from Odin Inspector, and you can remove it if you don't have the asset. It makes sure this field only shows up in the inspector when interactable is turned off, since that is the only mode where it actually does anything. Dangle angle sets how far the object swings on its first move, in degrees. Then we have a fixed dangle count toggle. When it is enabled, you get a single dangle count value. When it is disabled, you get a minimum and maximum instead, and the script picks a random number in that range every time the effect triggers. That small addition means repeated dangles never feel quite identical, which goes a long way towards stopping your UI from feeling a bit robotic. Just like before, the showIf attribute only gives us values to change if they match the kind of count we are going for. I really enjoy attributes like this, since they keep the component in the inspector easily manageable. The animation curve controls the easing of each individual swing, how it accelerates and decelerates. As most of the times across my scripts, picking one that starts low and ends high will yield the best results. Start behavior is an enum with 3 options. Don't play on start, play once, and play continuous. As with all the juicy effects in this library, I defaulted to don't play on start. Interaction controls round out the inspector fields. Interactable makes sure you can control its interactability, of course, and it will be checked in any of the upcoming interaction modes. Mouse button lets you specify which button triggers the effect in case you want to click it, and interaction type is the enum that switches between click, hover, pointer hold, and hover continuous. 2 events give infos about what's going on for subscribing scripts: onDangle started and onDangle complete. These are for anything outside the script that might want to react, like playing a sound, triggering another animation, updating graphics elsewhere in your UI, and whatever else you need. We finished this quite verbose header with some private fields. We have 2 coroutine references, one for a single dangle and one for the continuous loop. There is a wait for seconds for the delay between loops, a bool called isDangling to track whether an animation is currently in progress, and a stop endless loop flag to break out of the continuous coroutine cleanly if needed. Really, I only added this one because having any while true loops in my code makes me worry about having to call the task manager. The Euler angles get cached in start so that we won't have to read them every time at a later point. Onwards to the methods, and we'll start with a small but important helper. onDrawGizmoSelected lets us create a small visualization helper to display where the object we want to dangle's pivot is located. That's important to know to see at a glance, since we'll typically not see it while working on the parent object. This first line lets us define the color of the gizmo, and the second draws a sphere at the position in a specific radius. The position is where the location of the pivot is. If you always want to see the gizmo, rename your method to onDrawGizmo instead, but I'll typically only want to know its location while working with the object in question. onValidate runs in the editor whenever anything changes in the inspector. It does 2 things. First, if the pivot isn't set to custom, it immediately applies the new pivot value to the rect transform. You can see the pivot shift in the scene view as you change the dropdown without needing to enter play mode. Second, if start behavior is set to play continuous, it forces interactable to false, because those 2 modes are mutually exclusive, at least in the way I use this component. Awake applies the pivot one more time at runtime just to be safe, and initializes the wait for seconds. In start, we check the start behavior. Play once calls trigger effect immediately. Play continuous starts the continuous loop instead. Don't play on start does nothing. onDisable makes sure any routine gets stopped when the object is disabled, so nothing keeps running in the background. Trigger effect is the method required by the ISJuicy interface. If the object is interactable when it gets triggered, it triggers a single dangle. If it isn't, it starts a continuous loop. This is the one method that lets an outside controller trigger this effect without knowing anything specific about it, and it is being used by the sequencer I'll show at the end. Both methods also come with a context menu attribute, which means you can right-click on the component header in the inspector during play mode to call them directly. If you have Odin installed, the button attribute puts a clickable button right on the component instead. The public methods give you runtime control from outside. Stop endless loop sets the flag that breaks the continuous coroutine, and there is a set of setters for everything you might want to drive externally. That last setter also rebuilds the wait for seconds, because just updating the float wouldn't affect the cached wait, and that's already been created. The dangle method just starts a new dangle coroutine after making sure none is already being active. Dangle coroutine is the heart of the system, and welcome back to everybody who jumped here. It gave me some minor headaches while figuring it out, and it is a two-phase process. We start by firing on dangle started and setting is dangling to true. Then we resolve the swing count and double it, since each complete dangle is 2 swings, left and right. We divide the total duration by that number to get the duration per swing. This loop runs for every swing. Each pass through the loop swings a little less far than the previous one. By the final swing it reaches 0, meaning the object naturally comes to rest. Direction alternates by checking whether the index is even or odd. We then get the current angle and start with an elapsed time of 0. Over that duration, this interpolates from one to the other swing using the animation curve for easing and updates the Euler angles accordingly. Once the loop finishes, we make sure the angle is back to 0 again, so we won't run into any rounding issues for consecutive runs. Clear out the routine and call the event to notify any listeners. The continuous dangle coroutine is a while loop that runs until stop endless loop gets set to true. Each iteration it first waits for is dangling to be false. Without this check, the loop would keep firing dangle on every frame without waiting for each one to finish. Once it's clear, it triggers a dangle, yields a frame, waits for it to finish, then waits for the wait before starting over again. The pointer interaction methods each start with an interactability check and return early if it is false. If you don't want to write them all out by hand, you can implement them just like this. They all do more or less the same thing. They check if the type of interaction currently happening matches the interaction type value we set up and call for dangle. On-pointer enter and exit are the odd ones out here, since they can start and end a continuous dangle as well. This class finishes with 2 helpers at the bottom. getCurrentAngle reads the current Z angle and normalizes it from Unity 0 to 360 range into an -180 to 180 range, so the direction logic in the swing loop works correctly. isCorrectButton checks if the player used the specific button we defined in the beginning to click on the element. And if you enjoyed this so far, please give the video a like and consider subscribing. This is part of a series of tutorials for UI Juice you can plop into your game, and I'd love to hear which kind of effects you'd like to see next. Save your script and attach it to any UI element. Point object to dangle at the rect transform you want to swing, and start experimenting with the pivot dropdown. It gives a good impression of what kinds of effects you can get, which you can then customize further with the values below it. Let's see a controller in action that triggers multiple of these effects. I'll create a few elements on my canvas and set up the dangle wave in a way that fits each of them for this, all with different values for duration, amount to move, position of the pivot, and such. This is its own class and will work across juice effects in this planned series, and there are multiple ways to handle this. I'll show how to work with the interface here, but you could also create an abstract class all juicy effects inherit from, and call the trigger effect from there as well. I didn't go that route since I wanted to keep these already quite verbose effects a bit easier to handle, but let me know, would you like to see the next one use an abstract approach instead? This class is called Juicy Sequencer. It once again starts with an enum for the spacing mode. We'll either set a time and have the script calculate how to space out the animation based on child objects, or define the delay between each effect, or simply set it to instant to trigger them all at once. ShowIf is another one of Odin's handy attributes, and will make sure we only have to deal with either the total duration or the delay between effects entry based on what we set as the spacing mode. This system is coroutine based again, so we'll define one and its wait for seconds at the top, together with a value to hold the previous wait duration. This onValidate is a bit of an odd dangling, but a needed one. If we drag in a group of objects to fill the list will populate itself with the first monobehavior it finds on those objects, which, in my case, would be the image, not the juicy flip script. This onValidate gets called whenever there is a change in the inspector, runs through everything dragged into the list, and searches for the correct component by grabbing the isJuicy interface. Of course, there are 2 other scripts that handle this a lot more gracefully at runtime. resetList clears it of all its contents, addJuicyEffect adds it to the list, but it needs to be cast to a monoBehavior to function. Not as round as I enjoy things to be, so if you have a better idea, please share it in the comments. Trigger sequence can either be called from the context menu, the button, or from any other script outside, and will only do anything if there are children assigned to it. If we want to display everything at once, it will call trigger instantly and stop there. Otherwise, it calculates the delay based on which spacing mode we used, then checks if the delay matches the previously calculated wait duration. If it is different, we assign a new wait for seconds and store the new value. Really, this is mainly used for testing, where you want to switch between either of the modes while still in play mode. If you don't plan on switching at runtime, you can move the calculation and assignment without any need for the if check of the previous wait duration to awake instead. Stop sequence does just that. Sequence coroutine goes over each entry in the list. We can't assign interfaces directly, which is a major bummer, so we'll go with a list of monoBehaviors instead, and check for each entry if the effect is an isJuicy inheriting monoBehavior. If it is, we trigger the effect and wait for the specified duration before continuing. At the end, we free up our routine again. Trigger instantly instead does the same without any kind of waiting needed. Lastly, in onDisable, we stop any sequence still playing to make sure nothing shouts at us in the console window. Save this and head back over to Unity. You can attach this script everywhere, but the parent container for the effects you want to control makes the most sense of this. Add the game objects you want to control to the list, and yes, you can add really any kind of monoBehaviored game object to this list, but only the scripts that contain the isJuicy interface will be triggered. Head over to the play mode and give this another test. Did you enjoy this? Head over to the comments and let me know. If you want to learn more about Unity UI in particular, maybe consider subscribing too. Again, if you want to see more, please let me know and feel free to wish for a specific kind of juice effect too. Have a great week!